In this video, we will solve the following problem together. It's asking us how many ions of sodium are present in 5.07 grams of sodium nitride. If you'd like to try it on your own first, pause this video and try it. And I'm going to start off by dissecting what we need to do in order to start. All right. So the first thing here to recognize here is that this is an ionic compound, which is really saying that you have 3 sodium ions and 1 nitride anion. So when it's asking you for ions of sodium, you could really think of this as atoms of sodium, if that is a little bit less confusing. Really, it's just saying atoms with a +1 charge, because that's what a sodium ion is. So we could just treat this as atoms of sodium. And there are 3 sodium atoms or sodium ions in every 1 formula unit of sodium nitride. Okay, so it is giving us grams of the compound. So here, given is that we have 5.07 grams of sodium nitride as a whole. And what we're being asked to find is the number of sodium atoms specifically. So not how many sodium nitride formula units do we have, how much sodium alone do we have? And there are a couple of things to recognize here. So we don't have a direct relationship between grams and the number of sodium atoms. However, there are 2 things that can kind of get us there. Keep in mind that molar mass is expressed in grams per mole. So always make the connection that between grams and moles. Molar mass is what's going to get you there. So if you see grams anywhere in the problem, chances are you're going to have to use molar mass, because that is the only thing that will connect you from grams to moles. And moles can take you in whichever direction you need to go in. So somehow we need to get into moles. The other thing to keep in mind is that Avogadro's number means that 1 mole is equal to 6.022 times 10 to the 23. And that is referring to anything. 1 mole of any kind of particle will be 6.022 times 10 to the 23 particles. That could mean anything. It could be pieces of candy. You could have 6.022 times 10 to the 23 pieces of candy. It could be atoms. So that could be referring to atoms. It could be referring to molecules. It could be referring to any kind of particle. So if you see moles, or if you see atoms anywhere in the problem, it could be atoms, it could be ions. Avogadro's number is what's going to get you there eventually. And when you have established that relationship, notice that Avogadro's number will take you from atoms into moles. And molar mass is going to take you from grams into moles. Once you have that connection, you can build a bridge between those 2 concepts. So we don't have a direct relationship between grams and atoms, but we can use moles to interconvert in between them. So let's come up with a plan here. We are given grams of sodium nitride. Ooh, here I have my periodic table. I'm going to move that. I'll get rid of it for now. Okay, so I have grams of sodium nitride. And I know that the only way I can build a connection to atoms of sodium is I have to get into moles somehow. So the first thing I'm going to do is get to moles of sodium nitride. So that's the first place I have to go. And the piece of information that will get me there is molar mass, right? So I need molar mass of sodium nitride to get into moles of sodium nitride. Now, once I have that, I eventually want atoms of sodium alone, just sodium, not sodium nitride, so not the entire compound. I'm only interested in sodium. which means that once I have moles of sodium nitride, I really want to convert that to moles of sodium, just moles of sodium by itself, because I don't need the whole compound. I need just sodium. And I can get that using the formula subscript, because the formula subscript here is telling me that for every 1 mole of the entire compound, so 1 mole of sodium nitride, I have 3 moles of just sodium. And here I'm putting in the charge because the sodium here exists as a sodium ion. You could ignore it. The calculation will be exactly the same, so it doesn't particularly matter. That piece is what goes on that arrow, because that will take me from the compound to sodium alone. Once I have that, ultimately I'm trying to get to the number of sodium atoms. And when I have the moles of sodium atoms, well, I can use Avogadro's number to get to the number of atoms. So moles are the connection. And if you're ever completely stuck on a problem, turn it into moles, because chances are that's where you're going to have to go. So if you are completely confused and lost, think about how you're going to get to moles and then build your pathway from there. Okay, now we have a plan. So if you would like, you can pause this video, try to calculate this on your own, and then check in and see how we did it. Okay, so it looks like here I am going to need the molar mass of sodium nitride, which means, well, I have to calculate that. So I'm going to bring in my periodic table, which I got rid of. Okay. Here we are. So I need the sodium atom. Okay, I know this is really tiny. And then I need the nitrogen atom. So let's do that right here. Okay, so nitrogen is 14.007 grams per mole. And I'm rounding a little bit here. And then sodium is, I'm going to round this to 22.99 grams per mole. And then I do have to keep in mind how much of each atom I have in the formula. And it looks like there are 3 sodium atoms. So I have to multiply this value by 3. Okay. That gets me 68.97 grams per mole. The nitrogen we can just copy directly over because there's only 1 of them. So I'm going to add up these 2 values. And that is getting me that the molar mass of this compound is 82.98 grams per mole. So I need that piece of information for my pathway here. Let's copy this over. And we said the molar mass was 82.98 grams per mole of sodium nitride. Okay, so let's start with the grams of sodium nitride that were provided. And I know the first thing I have to do is take this into moles of sodium nitride. So that means I need to cancel out grams of sodium nitride. And to do that, I need to use the molar mass. So the grams of sodium nitride have to go in the denominator. And that gives us 1 mole of the entire compound. So now the grams cancel out and we are left with moles of sodium nitride. The next thing I want to do is take those moles of sodium nitride into moles of sodium alone. And it looks like here I have moles of sodium nitride. So I want to cancel that out. And in 1 mole of sodium nitride, we have 3 moles of sodium. And now the moles of sodium nitride cancel out and we are left with moles of sodium. And finally, when I have a mole of anything, I can convert that into the number of particles. So I have 3 moles of sodium and I want to convert that into the number of sodium atoms. In 1 mole of sodium, there will be 6.022 times 10 to the 23 atoms or ions of sodium. And that just comes from Avogadro's number. So now our moles of sodium cancel out and we have the number of atoms. And because this is an ionic compound, the number of atoms really means the number of ions. Okay, and now we're plugging everything in. So we're multiplying everything in the numerator and then dividing by the denominator. And that is getting me 1.3 atoms of sodium. Or you could say sodium ions. Up to you how you want to handle that. All right, so just remember, molarity or molar mass is going to take you between grams and moles, and Avogadro's number will take you between moles and the number of particles.